Okay. All right, so we are here. Applied math 10:30, and we are in the
I wrote in the chat too. You ain't see it.
oh, okay. I will. Thank you, babe.
Okay.
Um,
You're welcome.
we are in the fourth term, and we are in the third week of the fourth term, so this is moving right along. Again, we are talking about sequences and functions, and the goal is to get you to not only recognize a function, but to determine the rule that guides, or not, I'm sorry, to not only be able to identify a sequence, but to describe the rule that moves the sequence, and then to derive more terms from the sequence. And the standard, again, is just a guide for teachers so that we all are teaching our students the same content, regardless of where we are located. No child left behind. So, our agenda for today, we just had our community meeting. We're going to do a little warm up. We're going to do a lesson on using the formulas of a sequence, and then we're going to practice using those formulas. So, let's see what we have. All right, so here we go. Here's the warm up. I want you to determine the type: arithmetic, geometric, or neither. And then, what is the operation that is moving the sequence? According to my clock, it is 10:47. I will give you I'll give you 7 minutes. So 7 minutes is five of. So let's see what you can do. And then we're going to talk about it. Oh, damn. All right, we're going to take about 2 more minutes, good people. All right, let's see what we got, good people. We'll just jump on in. I will, I'll start where you start. Anybody have anything? We, again, do not, wait a minute. We do not have to go on. Oh, I see you. Oh, okay, okay. Oh, okay. My old heads. Everybody want to go to the past. That's what I'm talking about, y'all. Thank you, Deja, for bringing it to my attention. And thank you, ladies, for your responses. So anybody, what you got? Remember, your sequences can be arithmetic, geometric, or neither. So if it doesn't seem like you can find the pattern, it could be because there is not one, or not one that is consistent as you move through the sequence. Anybody? 11, 22, 33, 44.
Times 2, right?
No, only the first one is times 2. Go back and check it out. 11.
Times 1, right? Wait, hold on.
Wait. Check it out. You started with 11. You did something. Now you got 22. You did that same thing over. Now you got 33. You did that same thing again. Now you got 44. What are you doing as you move through the sequence?
Hold on, it's like 5 minutes.
Go ahead. Yep.
Okay.
Yep.
Is it 55 and 66?
All day. Yep. 55 and 66. So that makes it what type of sequence? And what did you do?
I just followed the pattern. I didn't really do the math. I just seen 11, 22, 33.
Oh,
I just went on.
What were you doing as you moved through?
Adding, right?
Yep, exactly. And how much were you adding, darling?
Was it 11?
All day. Yes, you were. So because you were adding, that makes it a red in Tom's house might eat Tom's ice cream. It's arithmetic. Yep, it is arithmetic because it is a constant adding of 11. Absolutely. All right, look at the next one. 15, 30, 45, 60. What are you doing? Tell me the next two. Then we're going to put in a type. And you're going to tell me what is the operation that you are continuously doing that is moving you through the sequence.
You add 15.
Add 15. Talk to me, math student. Yep. So again, because we are, oh, I'm sorry. Because we are adding 15, again, we know that our type is arithmetic. So what does that mean? What are the next two? What are the next two terms? You all don't have to leave her hanging out there by herself. You can jump into. We understand that we are adding 15, which makes it an arithmetic sequence. And we are sitting on 60. What are the next two terms of the sequence?
75 and then 90, I think.
All day. Thank you, ma'am. All right, so now. All right, so now we're dealing in fractions on the next one. Now we can either do it now or we can wait. But this is where we are so far. Now we can wait and do the fraction last. And we can do the others. Or we can entertain the fractions now, whatever you want to do. Nobody. All right, well, let's skip the fraction. Let's go to the next one. You had 1,000. You did something, now you have 500. You did that same thing over. It gave you 250. You did that same thing again. You now have 125. What are you doing and what are the next two terms? We're going to skip the fraction. I'm all right with that. So again, you started with 1,000. You did something that landed you with 500. You did that same thing over. And then you had 250. You did it again. You now have 125. Hello. So what are you doing? And what are the next two terms? I'll put it back up on present. Again, we are here. We are on 1,000. We skipped the fraction. We'll come back to that. What's happening here? Or any of the other two below it. Again, we don't have to do them in order.
Where you at, Hicks?
I am here. We started with 1,000. We did something. We then had 500. We did
Divide
that
by 2.
Oh, that's what I'm talking about. So if we divide them by 2, what type of sequence is it? Arithmetic or geometric? Oh, let me put the operation in. We are. So dividing by 2, can I say we multiplying by a half? Is that okay?
Say that again.
You said dividing by 2. Can I say, do you mind if I say we multiplying by a half? It's the same thing.
Right.
I'll do it this way. Dividing by 2, which means we are multiplying by a half. Because, yeah, you're dividing everything in half. Okay. So now, again, okay, so let's go back. So let's divide by 2 then. What is 125 divided by 2?
See 250.
No, don't multiply it by 2. Divide it by 2. You're going the other way.
Okay. Oh, my fault.
Yeah, 125 divided by 2. Y'all can break out them calculators. I'm
Yeah, C2.5.
62.5?
Yeah.
62.5. Okay, and then divide that by 2.
31.25.
31.25.
Right.
All right, thank you. All right, so because we are dividing and or multiplying, depending on how you look at it, what is it? Is the sequence geometric or arithmetic?
The G word, right?
Yes, you be killing me with the G word. Yes, that makes it a geometric sequence. All right, so next one. 3, 6, 9, 12. What would
+3.
who?
+3.
+3 is working, yes. So +3. So if you're adding 3, what type of sequence is it?
The A word.
The A word. You are killing me. +3. It is arithmetic. You are too funny. All right, it's arithmetic. Oh, I don't know what I just did. Oh, my internet just went a little swervy. I don't know what happened there. Control copy. All right, so it's arithmetic. And so what would be the next 2 terms? What follows 12?
15.
And then?
18.
Thank you, sir. All right, so 15 and 18. Okay. All right, last one. And then we're going to come back to that fraction. Life is not in whole parts.
Yeah, times 4.
Who?
Times 4.
Nope.
It's
Everything could be, nope, because 0 times 4 does not give you 4. But everything else, yes. 4 times 4 is 16. 16 times 4 is 64. Yes. But doesn't work when we moving from the first term to the second term. Good morning. Glad you joined us. So for that last one, not times 4. Anybody else have another proposal? Remember, we have 3 options, not just 2. No? Is there a pattern? Because again, try a couple things, see what you see. Is there a pattern? Oh no. ladies and gents, the last one is neither. Because yes, in the beginning, the rule that would come to your head first would be multiply by 4. And it does work as we move from second term to third term to fourth. But it does not work when we move first term to second.
Miss Hicks, I'm back in your class again.
Hi, love.
And I
Okay.
have an actual math question for you that I think I need to join your lab today.
Okay. But yeah, so first term to second term, we can add 4. That'll get us there. But then it falls apart because we can't add 4 to get to 16. But yes, so in this case, it's neither. It's neither. It starts one pattern, then it flips to another. It starts addition, flips to multiplication, so it is neither. So now, ladies and gentlemen, let us look at the fraction that nobody wanted to touch. So now, first of all, when you look at the fraction, look at which portion of the fraction is changing. So you have 1/3, 1/9, 1/27, 1/81. So think about which portion of the fraction is changing. And then looking at the portion that is changing, how is that portion changing? Okay? So, I'm going to stop my share for a second so I can show you the board. All right, so let me take this down from last period. All right, so this is coming in.
Oh shoot, I had my sound off. Did you reply to me?
No, not yet. I said okay because you said you're gonna have to join my lab. That was the last thing I heard you say.
Okay, I didn't hear. I like had my whole computer on mute, so I was like, oh, I'm not hearing anything.
Oh. Okay, y'all. So here we go. We have 1/3, 1/9, 1/27, and 1/81.
The bottom of the fraction being multiplied by 3.
Exactly. So the bottom of the fraction is being multiplied by 3. What's happening up top?
It's staying the same, so it's like being multiplied by 1.
Exactly. Therefore, the numerator is being multiplied by 1. The denominator is being multiplied by 3. Whoop, there it is.
It was that simple?
Yes. I knew when everybody was silent, I said, they overthinking this thing.
Yeah.
But yeah, absolutely. Just like that, voila. But because it looked like a fraction, you all said, I don't like fractions and I'm not doing it. I'll let Hicks figure that one out. And I appreciate you all.
Yeah, that would have been me too.
Yeah, I appreciate you all for relying on me. I do. But yes, yep, just that simple. You know, again, as long as when that numerator is staying the same, concentrate on the denominator. That's what's doing the movement. So, yep. So now we're going to go back and tighten that up on our good screen. So we know that we are multiplying by 1/3. So we are multiplying by 1/3. And then, so since we are multiplying, that means that we understand that it is going to be geometric. And then now our remaining 2 terms aren't as mysterious. So, what is 3 times 81?
243.
Yep. So that's 1 over 243. And what comes after that? What is 3 times 243?
729.
729. Okay. So what we see is our pieces in this one are getting smaller and smaller and smaller. Okay. So our pieces are getting smaller and smaller, but it's okay. So yeah. So if those were not the responses, your responses, go back and check yourself. Again, that last one was neither, because we started out adding 4, but then we switched and we went to multiplying by 4. So that could be neither. But all of the others, I agree. Yep. So that's a good thing. That's a good thing. So I'm glad it's coming along. It's coming along. So now, there are times when we talk about sequences, and like in this, all right, they gave us 4, we figured out the next 2. So in essence, they gave us term 1, term 2, term 3, terms 4, and we had to figure out terms 5 and 6. Those were just the 2 terms that followed. But sometimes they'll give us 4 terms and then tell us to find a term further down in the sequence, the 11th term, the 15th term. You only in class for 50 minutes. You don't have time to keep adding 11 and 11 until you get to the 15th term, if we were looking at this first sequence. So there is a formula that you can use that can help you derive those terms that are further down in the sequence. Okay, so now let's move forward. So for an arithmetic sequence, this is the formula. Okay, so I want you all to write this formula down, because we will probably only be able to discuss this one. So if our sequence is arithmetic, they tell us that we can find any term in the sequence if we take the first term of the sequence and add it to the difference that we find in the sequence times whatever number we're looking for minus 1, or times the number before the one we're looking for. But we're going to work that out. So here's our arithmetic sequence. 3, 7, 11, 15. So what's the difference? How is the sequence moving? We started with 3, went to 7, went to 11, went to 15. So A and B, what is the difference? And what are the next 3?
Right, you add 4.
Yep. All right. So we adding 4. Oh, sorry. So if we adding 4, what are the next 3 terms?
19. 23.
You said who? 19 who? Go ahead, I'm listening. 19.
23.
23. Okay, bam. All right,
27,
so
right?
you said 19, 23, And what's after 23?
27.
27. Okay. So now, even with that, we still only have 1, 2, 3, 4, 5, 6, 7 terms. The next asks, find the 20th term. So now, let's pick our pieces. So they say A is the first term of the sequence. So I'm going here. All right, so if A is the first term of the sequence, then the value of A is, okay, here we go, 3. We found, the difference to be a +4. And the N would be the term that we're looking for. So the N would be 20. Okay, so, all right, so our A value is 3. Our D value is a +4, and our N value is 20. So now, let's see if we could put this thing together in this formula and figure out what the 20th term is. We have about 2 minutes left in the class. Did anybody figure it out? And if not, that's okay, because we can start right here on Thursday. But I want you to see, that's your assignment for Thursday. Somebody come back with the 20th term. Tell me what the 20th term is. So write down the formula. We have the values of A, D, and N. So on Friday, and I'm writing this down, on Thursday, I keep saying Friday. So on Thursday, we are going to find the 20th term.
5 hits.
Who?
95.
95. I don't know. That I'm gonna put it up here as a proposal. Okay, so when we come on Thursday, we're gonna see if the answer is 95. That's the proposal. Okay.
I see you. Like, I gotta leave real quick.
Yeah. Oh, the class is over. Thank you all so much for coming. I appreciate you. I look forward to seeing you on Thursday. And again, we are we're in the 3rd week